This is Unit 4, Lesson 6, Part 3, L'Hopital's Rule. This is the finer part of the lesson, and we're going to talk about AP-style applications of L'Hopital's Rule. So, example 9. The table to the right, it says below, but to the right, gives values of a twice differentiable function, y equals f of x. Use the table to find the limit. If it exists, justify your answer. Okay, so what we can do is we can start with a direct substitution. So we are looking for f of 3 times negative 2 plus 2 over negative 2 squared minus 4. So this is going to be f of 4, or negative 4, over 0. F of negative 4 is 0, so we have 0 over 0. So we have the indeterminate form. So we're going to apply L'Hopital's rule. So the limit as x approaches negative 2 of f of 3x plus 2 over x squared minus 4 is going to be, now we're going to take the derivative, the denominator will just be 2x. The top, we're going to have to use the chain rule, so it's going to be f prime of 3x minus 2 times the derivative of 3x minus 2, which is 3. Whoops, and I forgot my limit. So I got to make sure I put that in there. Okay, so direct substituting, we are going to have f prime of negative 4 times 3, and that's going to be over 2 times negative 2. So we get 3 times f prime of negative 4 is 8 over negative 4, so we get negative 6. So as I've stated many times, the AP test loves their tables. Okay, number 10. Use the graph y equals g of x shown below to find the following limit if possible. Use proper notation to justify your findings. Okay, so we're going to take the limit as x approaches 3 of g of x divided by x minus 3. So what we're going to see here is at 3, so if we go to our graph where x is 3, the value of g right here is 2. So we are going to substitute that in, so we get 2 over 3 minus 3, which is 2 over 0. This is a limit that does not exist. It's not L'Hopital's rule. I'm going to be careful with this. Because we don't have an indeterminate form, we have 2 over 0. So you want to be careful. L'Hopital's rule does not apply here. It is possible to have an undefined limit. We have had lots of those, and they're not going away just because we have a new trick in our bag. Okay, so be careful about that. Number 11. The differential equation for the curve y equals h of x is given by dy over dx equals 3x over y plus 2. Given that h is twice differentiable, and h of 3 equals negative 1, find the limit as x approaches 3 of h of x plus x minus 2 over the natural log of 7 minus 2x. Okay, so a couple things I want to point out. First of all, we have this point, which is 3 comma negative 1. We have h of 3, which is negative 1. And in our function here, we can think of this as 3x over h of x plus 2. Okay? It'll make taking the derivative a little easier because remember, y is defined as h of x. So if we try to do a direct substitution, we know that h of 3 is negative 1, and then we're going to add 3 and then subtract 2. In the bottom, we're going to take the natural log of 7 minus 6. So we get 0 over the natural log of 1, which is 0 over 0. And this, of course, is indeterminate. All right, so what do we do with that? We use L'Hopital's rule. So the limit as x approaches 3 of h of x plus x minus 2 over the natural log of 7 minus 2x is going to equal the limit of their derivatives, the numerator and denominator's derivatives. So that's going to be h prime of x plus 1 over 7 minus 2x times negative 2. Okay, so substituting and simplifying this a little bit, h prime of x is that function right there we are given. So we have 3x, whoops, I need my limit. Not ready to substitute yet. So this is the limit as x approaches 3 of 3x over h of x plus 2 plus 1 all over 1 over 7 minus 2x times negative 2. I'm just going to leave it like that because we're just going to substitute anyway. All right, so substituting. So we have 3 times 3 over, and remember, h of 3 is negative 1 plus 2, and then, of course, we have that plus 1. And our denominator is going to be 1 over 7 minus 6 times negative 2. So simplifying this, we get 9 over 1, which is 9, plus 1. We have 1 times negative 2, so we have 10 over negative 2, which equals negative 5. Okay, next, our final example, actually. Find the limit if possible. Give a reason for your answer. Now, if you think about this, we would have to do L'Hopital's rule 99 times to use it. So there's got to be an easier way to go through this. So you always want to think before you start jumping into a problem. So let's consider the hierarchy of how these functions grow, again, like we did in one of the previous videos. Okay. So our two functions are 2 to the x, we'll let that be f of x, and g of x is going to be x to the 99 power. So what we want to notice is the limit as x approaches infinity of our f of x is going to be infinity, because we have, that's an exponential growth function. And the limit as x approaches infinity of x to the 99 is also infinite. I mean, we have a polynomial function that's growing. So we do have the indeterminate form. So what are we going to do with this? I personally do not want to do the derivative that many times. So what do? We talk about the hierarchy. So what we can say is applying L'Hopital's rule repeatedly will yield the limit as x approaches 99. Oh no, I'm sorry, x approaches infinity of 2 to the x over x to the 99 is approximately equal to the limit as x approaches infinity of some constant k times 2 to the x over 1. And this is unbounded. Okay, so the limit does not exist. So you don't have to go through that. You can reason your way through this one. And that's the end of our discussion on L'Hopital's rule. So we will be going over this in class tomorrow, and that's the end of the unit as well. And we'll do some problems and then review for the unit test.